So yeah, Taylor Brook project, I think you've probably heard about it, but we really haven't been having too many talks or that sort of thing, other than in Toronto. Derek presented on my behalf at the CIM in November. I was down with a non-COVID flu, but very, very ill. So yeah, let me just launch into it. It's a different story than the two you've just heard. We are true grassroots explorers. So we are trying to find something completely new. I won't go into you know, the whole story behind the need for nickel. It's exactly the same as what Gus was talking about. For copper, we need much more than's ever been mined historically in order to meet the demand to electrify the electrify the economy. Canada is a great place to look for nickel in that we have Voisey's Bay, which you know well, but as well, 3 other world-class mining camps at Raglan up in northern Quebec, Sudbury in well, we call it Northern Ontario, but Northerners scoff at that, and Thompson, Manitoba, all world-class, all substantial. Sudbury and Thompson have been in production for decades. Voisey's Bay and Raglan are both entering their 3rd decade of production. What's important about them is they produce class 1 nickel, sulfide nickel, which is entirely different than lateritic nickel, and that they're very, very high grade. These things, they are immune to commodity price cycles. They're so good that they just power through all of that. So you know, it doesn't matter that that nickel prices have dropped. We are looking for something where it'll be a slam dunk if we're successful. And we have 2 projects actually in Newfoundland and Labrador, both that we optioned from Altius and now own 100%. And in both cases, what we wanted was to see evidence of high grade. And you can see at Taylor Brook, where we now think we have a very, very large target, that intersection you see there, I guess there is a pointer. There we go. 2.79% nickel, you know, that's substantial. Anything over 1% nickel would be called high grade, and 2.79% is sort of a Raglan grade. That's substantial. Our other project, Florence Lake, which I won't talk about today, it's up in Labrador. It's a greenstone belt project previously worked by Falconbridge, but again, it had what we wanted, and we controlled the the entire area of nickel prospectivity. So that was a very, very important step for us. The team, it's myself, and our board is very, very experienced, including 2 people that are now involved with Firefly actually. But you know, when we picked these properties, this was specifically what we wanted. We wanted district scale potential. We listed in July of 2021, and we had done the deal just before that. I had a relationship with the Altius guys, and Lawrence and I were talking an awful lot. Went through their entire portfolio of nickel projects, and these were the 2 we picked. The point here is just that, you know, we're doing grassroots exploration. We're advancing both properties as well as we can in trying markets, but you know, we're just moving things along. And Taylor Brook, our flagship property, we've had 2 drilling programs now. We know what we're dealing with there, and we're very, very excited about the plumbing system that we've identified. Just where they are, I don't have to tell any of you, but you know, Taylor Brook, we did that deal first just because it was more accessible. Everything about it is cheaper exploration. It's an hour from Deer Lake, and you know, big logging roads in that area. This is really the crux of the matter, though, in terms of how we view the nickel world. That shaded area, that is above 0.6% nickel and more than 100,000 tons of contained nickel within the deposits or the mines. And these, historically, are the only ones that have ever been mined, other than Kevitsa, which is a Boliden mine in the middle of their big mining complex in Sweden. The others, you know, just don't quite make the grade. The ones on the left are too small. We looked at all of those. We could have had 2 out of the 4 actually. And the other group down there in the far right, that is a group of Canadian juniors that hope that everything's going to change, and low grade, extreme large tonnage projects will become economic. We didn't want to go that way. We decided we'll go for what's tried and true, and try to find ourselves an Eagle or a Raglan. And you know, as I mentioned, these are slam dunks. Reed Brook, that's its reserve statement from a couple years ago. You know, even at these depressed prices, it's still $500 a ton ore. Raglan, same thing. And it's, you know, they just announced their new mineral reserves. They've got 3 more decades of production there. So these things grow as well with time. Once you find the initial deposit, you'll find more. And that's really what the previous 2 talks were demonstrating as well. So this is what's called the Leyden Showing. This is the discovery outcrop, and that's a lady you probably, many of you know, Dawn Evans-Lambswood. She was there on behalf of Inco in 2003 at Altius's invitation. And what you're seeing there is a breccia. You can see there's dark zones and light zones. And the dark zones are the massive sulfides or near massive sulfides. This lighter stuff, it's disseminated. There is pieces of Grenville gneiss in the breccia. The host rock for the breccia is actually this guy down here. It's a gabbronorite. It's very, very similar to a very, very large gabbro complex just to its east. But this thing grades about 3% over 2 meters. So it's very, very interesting. It's demonstrating the high grade we want to see. But what it doesn't have is width yet. And really what we've been trying to do is figure out how big it is. One thing that really excited us was this picture down on the right here. The breccia is very extensive, and this is telling us that it's a massive system. It's dynamic is the word the industry uses, but it had a lot of power. It was punching its way through, and you know, it gives us scalability, if you will. Infrastructure, I think a lot of you know where we are, and you probably snowmobile up there, but it's the Taylor Brook Road, which comes off of Highway 420 going up to Hampton and Sops Arm. We use Eastern Analytical exclusively for all of our assay work. Our drillers are majors based out of Deer Lake, so you know, it's just excellent exploration. This is Chris Verbitsky's camp that he maintains for Fishhawk Gold, his private gold company. We share it with them, and as you can see, it's a permanent camp, which again is a very, very lovely option, or a lovely luxury. It was put in for the hydro line, though, coming down from Labrador when they built that. So you can see how close we have power to the project. So the story is that we are at the edge of the Canadian Shield, the edge of the Grenville province here, Rifted Valley, the Deer Lake Basin, and that's a classic sort of situation for nickel deposits. What excited me from day one and Derek was that the Taylor Brook Gabbro complex, a layered intrusive complex that's Silurian in age, is sitting there right beside this showing that's out in the Grenville rocks. And we've been trying and truly succeeding in showing there's a relationship between the two. In other words, past workers and researchers thought that Leyden was Grenvillian in age. And we have demonstrated that not only is the host rock to Leyden Silurian in age, the mineralization is as well. So it's all interrelated, and that makes it a very, very enticing situation for nickel explorers. First thing we did was we flew a VTEM survey, and you could see there's a whack of conductivity, shallow conductivity in the Leyden area, and some more down in the Taylor Brook Gabbro South Lobe. The South Lobe's really interesting because it's highly, highly magnetic. And as well, there's a known gravity anomaly there that was found when Memorial University did a gravity survey, ostensibly to outline the Deer Lake Basin, but this is the highest gravity anomaly in Western Newfoundland. So this rock here is dense and obviously, iron rich given its magnetism. And as I said, we've been trying to find the relationship between the two. Magnetically from the VTEM, you could see this feature here. And this, we confirmed, was our gabbro-norite host rock in many places. So we were finding gabbro-norite down here, and of course, gabbro and noritic rocks within the South Lobe. Moving on, we flew a more intense magnetic survey, a heli-GT survey, 50-meter line spacing, and we've done a hell of a lot of soil sampling. I think it's over 8,000 soil samples now. The better resolution mag allowed us to see this fault, which is offsetting the stratigraphy in a right lateral sense. Again, this feature here, this mag feature, we're finding gabbro and gabbro-noritic rocks along here, identical to what we were seeing at Leyden. Great soil anomaly here. This got up to 3-4 times what we see at Leyden. And here at just in the South Lobe of the Taylor Brook gabbro, we got that sample. Big in copper, so that kind of makes sense from a layered intrusion sort of model. We've extended it over 600 meters. It's coherent, it stays together. But still, if you look at our soil sampling and you look at the magnetics, there's nothing to really tie these two things together. And, whoops, sorry, wrong one again. What we've now done is we've flown what's called an MT survey, magnetotelluric survey. And what we have is this beautiful resistivity low that extends for about 13 kilometers. That's the South Lobe of the Taylor Brook gabbro there. Leyden sits here. And we show Boise's Bay footprint here just to show the scale of that system. These are all connected. They continue to grow. Valley's announced fabulous intersections down below Reed Brook. Reed Brook's the conduit leading to the ovoid zone and eastern deeps. And we really think that, we have something similar here at Taylor Brook. It's early days, but we've got a lot to do. These horizontal magmatic intrusions or conduits, you need the sill-like structure as well as the dike-like structure for sulfides to settle out of the magma. And what pleased us is that at Leyden, we have a sill-like feature and we had this vertical feature. And what we tried to do was, was sort of hit the areas that might look good for trap sites. But every hole we did borehole EM on as well. So we were looking for big conductors down there, confirming some of the shallow stuff that we knew about with these holes. The MMT, the airborne survey, was actually flown after we did the groundwork and while we were drilling, because we knew now that CSAMT worked. Here's our sill. There's this vertical feature that Derek and I got really, really excited about. And Leyden sits up here. So it was all kind of making a lot of sense. That section goes through here. There's Leyden. And you can see the MMT section actually is showing two much more prominent dike-like features out to the east. And that's what the plan here is showing. Leyden's here, there's a little bit of it there, and then this is the main conduit. This is what got us really, really exciting. Leyden exists as part of a sill, and that's what we're seeing here, is sill-like features. It comes to surface in various places. It has potential, and we see that at LIT1 and TBSL1, or at Leyden, I'm sorry, because that's, that is the way sulfides often come out of the magma. So the dike is very, very much our focus, but we're continuing to evaluate the sill as well. MT is very, very important. So we're looking at resistivity lows. It doesn't find conductors per se. It's not powerful enough to do that. It's all natural currents. And the thing about resistivity lows is they can be a lot of bad things. It's most commonly picks up water or salt water. So we were very, very pleased that this is what we got. We got our gabbroic magmatic rocks. We know that they're Silurian in age, and we got some stringer sulfide. So very, very important technical step. We have the tool now, in other words, to trace our plumbing system. What we know about Leyden, and we've drilled quite a bit there over the last 2 years, is it stays narrow everywhere we've hit it, and we've hit it down to about 200 meters depth. But I don't know if you can read this, but this is 0.6% nickel over about a meter, and it gets up to 3% over a couple meters in this direction. So we seem to have a nickel vector, if you will. The big breccia system I showed you that picture of sits here. Conductors thus far that we found, these are these horizontal or these square plates that you're seeing, rectangular plates. We've got some good ones, but you know, you want to get up to really high conductors, and you know, we only see that around Leyden. The weaker down here, weaker down here. So it's all kind of telling us that, you know, Leyden is mineralized and Leyden is interesting, but Leyden isn't the main event. This is the drilling we did this winter, and this was because we had ground CSAMT survey, lots of resistivity lows. There's Leyden right there, and you can see we cast a wide net. I was trying to hit most of these things, and what we now know is that the good breccias we hit here, even though they were visually stunning, they're not carrying much nickel, and it's the offset equivalent of Leyden. And Leyden in turn is offset, if you'll just bear with me. These are all the sections. I got to race through here though. Leyden is offset by these two faults to this area here, and then it joins up with the Taylor Brook magmatic trend, and that is the focus of our work moving forward. Give me 2 seconds here. 4 areas that we've picked out. Each of them is going to be hit with line cutting, CSAMT, IP, and then drill holes and borehole EM. So that's what we're excited about, and that's what we'll be doing this summer.
Thank you.
Thanks a lot.
Thank you very much.